Burn.
Good morning, everyone. I've just been receiving quite a few emails off you about the NMR, so I want to spend a bit of time going through it. Now, please don't worry. I did assume you'd already done it a bit with Michigan, but we'll get through this. And remember, if there's anything you don't understand, get in touch with me, which is what some of you have been doing. You know, there's no point in rushing on to the next thing when we haven't nailed this. So we've got plenty of time. Let's work hard on it. So I'll just say good morning, and do you want to say good morning as well? Because I know you like to say good morning.
Good morning.
All right then. Now I'm going to work through an example, and I'm going to concentrate first of all on carbon NMR. So this was 2 days ago lesson. Don't worry if you haven't quite finished it, just as long as you're doing your work. And then I'll do a hydrogen NMR example as well. So I'm just going to stick with this first one here, and hopefully this will make life easier for you to understand. Like I say, it's hard teaching this stuff from a distance, but let's just try our best, that's all. So we've got this molecule here. You recording the paper, Em?
Yep.
Good lad. OH and OH. Now there are 1, 2, 3, 4 carbons in this molecule, but this molecule is symmetrical. So we're going to look at this in terms of, let me just draw the full displayed formula. So CH3, C OH, C OH, CH3, and obviously then we've got hydrogen there, and we'd also have, I think that's about right, isn't it? Yeah, right. So we've got hydrogen there as well. Do me a favour, Em, will you pause that video a second so I'll do it. Sorry guys, I drew it a bit bigger because this one was getting a bit messy over there. So now if we look at these, we're going to look for carbons only, because carbon NMR just looks at the carbons, and we're going to see the environments. So for example, now this carbon is attached to a carbon with an OH. This carbon is also attached to a carbon with an OH. So we're going to call this carbon 1 and this carbon 1. In fact, because this molecule is symmetrical, those two are exactly the same. Now the next one, then we've got a carbon which is attached directly to an OH and a CH3, and this carbon is attached directly to an OH and a CH3, and obviously this side as well. So these two are exactly the same as well. Okay. Now, because this molecule is symmetrical, there are only actually 2 different carbon environments. And what I've done now as well is I've printed off the. This comes from the data book that you get given. So carbon NMR. So what have we got first of all? We have a carbon-carbon. And we've also got a carbon attached to an OH group. So let's do the OH group first. CO. Let me just check that's the right one. It's not CCl. CO. So we're looking for one that's between 50 and 90 on the spectra. So the chemical shift for this one should be between 50 and 90 ppm relative to the TMS. This one, because again the molecule is symmetrical and this carbon is exactly the same as that carbon, will also be 50 to 90. Now this one here, we've got a carbon attached to another carbon, attached to another carbon. So we're looking for CC, which will be between 5 and 40, 5 and 40. Okay. So now, if I look at the spectra, which I think I wrote, let me see, so we're looking for 2 peaks, and we're looking for peaks between 50 and 90.
10 seconds.
Okay. 50 and 90 and 5 and 40. So this one's got 2 peaks. Let me check. It's not the other one, mind. Let me just check. 1, 2, 3. 1, 2, 3. Right, so it must be the spectra because there's only 2 peaks. We've only got 2 carbons, 2 different carbons. This one is between 5 and 40 tick, and this one is between 50 and 90 tick. So this one shows the spectra for the molecule butane. Well, I should have used this really. Butane, my accent part of it. Butane 2,3 diol. This one says butane 1,3 diol. That's definitely should be 2-3 dial, shouldn't it? Because that's carbon 1, carbon 2, carbon 3, carbon 4. We found a mistake there, so I do apologise. It's booting 2-3 dial. On me now. So that is carbon NMR. We're looking for the different carbons on a molecule. If the molecule is symmetrical, then they tend to be exactly the same. But you should be able to draw it out and see this. But it's just literally looking at the carbon environments. Have another go at doing the spectra. Doing this activity. So have a look now at this next molecule, which you should see has 3 different carbons. Now the reason why 1 and 1 are the same is because they're attached to the same molecule there, and it's totally symmetrical there. I have put the answers on there, but please do me a favour, ask me any questions, because that's my job. I'm trying to help you out as much as I can. I'm going to pause the year 13 stuff. I've already made a couple of lessons, but I might save that for next week now. And I'm going to go through one of the 6 marker questions on the past paper you've done. That you're all doing a fantastic job. But like I say, there's no point in just rushing through this and understanding. So please keep asking those fantastic questions. If you're struggling, let's get this sorted out now. I hope that this helped. I'm going to do the same for the proton NMR, but then I'm expecting a bit of feedback back as well, okay? So that'll do for now. I'm going to say goodbye, and I'll make another video in a bit. Emmett, my man, do you want to say goodbye?
Goodbye.
And we'll see you all soon.